Good morning, good afternoon, and welcome everyone to the 6GSymposium Spring 2022 edition. My name is Ala Murad. I'm a Senior Director at InterDigital, focusing on the evolution of 5G towards 6G. The event starts today with focus on the strategy, where we will be defining the priorities, the scope, the timelines, and the stakeholders playing into 6G. Tomorrow, the focus is going to be pretty much around the regulatory and the business landscape, followed by the third day, which will bring a deep dive into the technology innovations that will take us into 6G. So before we kick off the first day today, a couple of housekeeping notes. For all the audience, there is a Q&A box that you can please use to address your questions to the panelists. And the second housekeeping point is for all the audience, you should be able to watch on demand all the sessions from next week. So with this, I would like to kick off the event with the first session, the keynote session that's titled The Path Towards 6G. With me in this session, there's Afif Osairan, Director of Industry Engagement and Research at Ericsson, and Eric Hardouin, Vice President of Ambient Connectivity Research at Orange. So to set the stage a bit before handing over to our first keynote speaker, Afif, if you can move, please, Anthony or Alex, to the next slide. So the journey to 6G has already started with two tracks in parallel as customary. The first track being the advancement of 5G in a backwards compatible way. And the second track being very much a revolutionary track, bringing advancements or a new state of innovations, actually, that will meet the demand of the service scenarios in the next decade and beyond. So, like in every generation, there is always an inflection point where this inflection point will see the transition from the evolutionary track into the revolutionary track. So for 6G, this inflection point is anticipated to happen around the 2025 timeframe, and that will be supported by significant advancements in the technology trends like above 100 gigahertz, reconfigurable intelligent surfaces, AI, ML fusion with wireless, sensing fusion with wireless, and so on. So with this short introduction, I'll hand over to our first keynote speaker, Afif, to take us through his insights from the vendor perspective. So Afif, over to you, please.
Good morning, and thank you, Alan. I'm just sharing my screen, and please confirm I'm moving into full screen mode. Perfect. Okay, thanks, Ami, for the introduction. So it's my pleasure this morning to be here and to talk to you about, the 6G journey. Remember 1.5 years ago at the same symposium, as a matter of fact, some of us came and spoke, about the 6G journey, where we are. And I can assure you, of course, we are still at the beginning, isn't it? We are trying, to scratch the surface. We have ideas, but we are not yet, we don't really fully yet, what are the main components. We have identified, the major use cases, but the killer applications still to come. And as well, we have ideas, we have conversions, as a matter of fact, on what are the technologies needed in order to address these use cases. But before I start talking about 6G, I would like basically to start from the present, because I think this is very important. What lessons can we learn and how this present will bring us first to the near future and then to the far future. Looking today where we are in terms of 5G deployment, 5G has been so far building, I would say, very fast compared to 4G. We have, as for the end of last year, more than 6 million subscription. This is excellent, I would say, compared giving the short amount, couple of years time, where 5G has been started to be deployed, at least in volume.
Afif, sorry to interrupt you, but are you meant to share your screen, right?
Yes.
Yeah, yeah. If you can please actually share the screen, because the audience isn't able to see the screen yet.
Okay, apology, because let me see. Okay. I'm trying again. Can you see my screen now?
Yeah, absolutely.
Okay, my apology. I thought basically I was sharing. Okay, fantastic. So yeah, looking where we are today, the first indicator, I would say, the number of subscription of 5G. We have, as I mentioned, substantial amount of subscription, but still, at the beginning of the journey. What do we expect projecting for the next 5 years in 2027? As you can see on the bottom blue, they will be roughly around 4.5 billion. So even in 2027, 5G would not have reached the top, I would say. And if we are talking, 6G will happen in 2030, meaning, that once 6G eventually will be deployed, 5G will be at the top, isn't it? So there is here a potential that things will be even pushed forward. And I think, having 6G begin earlier, this is probably not very realistic. Another indicator is looking, how much of the population of are being covered by 5G. And remember, many of these networks, they are currently non-standalone, meaning relying on 4G and LTE. So there are currently around 35% of the population, you can see here, being covered by 5G. And we will reach 75 by 2027. Remember, I think LTE should be like above 90% and of the population, and the cellular technology, as a matter of fact, 95%. The third indicator is how much consumption you will use, how much data you are using today, and how do we foresee for the future. If we look at the current mobile consumption average, this is 11.4. If you more zoom in 5G, I don't have it here in the figures, but it's a double of this figure, around maybe 24, and mostly in Korea, we have seen this average where the first deployment came into force. In 5 years' time, they will be only a factor, I would say, of 4 of data rate increase. Of course, this is not so much compared to the step or to the jump, what we have seen between 4G and 5G. We have seen, as a matter of fact, of traffic increase around like 200 times. Then the third, I would say, indicator is the number of non-mobile broadband. And why this is important? Because we have always said, at the beginning of 5G, there are it will address, non-mobile broadband, other verticals, and non-consumers. And IoT are coming into forces, but still, we are not fully there. We have more than 14 billion connections. Only less than 20% are based on cellular technology, maybe narrowband IoT and LTE-M. And in 5 year times, the growth in cellular will be higher than the general growth. So it will be maybe half of these connections, the 30 billions, but still, we are not entirely there in terms, of what we have said, massive amount of connections. So the conclusion, what I draw here, what we have claimed at the beginning to happen at the beginning of 5G, it's happening, but progressively, and might happen at the end of 5G. So once 6G will arrive, meaning, some of the promises of the 5G will happen really, either before or just at the beginning. Now let's see, what exactly the expectation from 6G and what are the main scenarios, and as well, the technologies. On the top, you can see, this is not novelty. We have spoken about it. I'll complement it so far, what we have progressed, I would say, by our internal discussion within Ericsson. So if I start on anti-clockwise by those 4 category of use cases, which will be leading, which we have to address. Connected, sustainable world, and this is of crucial importance. We have put it, also on the top of our agenda. And why is it important? I will explain. First, we are shifting. It's no longer we are talking about, we would like to decrease the consumption of power. This is not enough. We would like to have more energy efficient networks. This is not enough. We would like to have more spectral efficiency. This is not enough. Actually, we have set the threshold much higher. We would like from the beginning reaching a sustainable world. And what does it mean? It's not only reducing the consumption, but making sure, addressing, a fully sustainable world and helping to reach a circular economy. Let me give concrete examples, like helping, in reducing the waste, helping the whole supply chain being basically making things more recyclable, trying these components to be less wasted, maybe extend the duration of not only the network of the devices, helping not only the ICT sectors, but also other sectors, to fundamentally, reduce their basically CO2 pollutions. And ultimately, we should rethink how, the implication of the business model, are the current business model as we are operating sustainable? And I believe they are not. And we should lead the way to completely change our thinking, our philosophy, how we live, and how, we interact with the whole world. The second category of use cases, going anti-clockwise again, is those connected intelligent machines. You will tell me, of course, we are having machines, we are having more machines being connected. Yes, and I have seen the previous numbers, we're still not there of very massive amount of machines. And here we are talking also about intelligent machines. So this is maybe machines completely independent, taking decisions, and those decisions, of course, should be based on certain rules, abiding, by the law, and certain rules having some ethicals as well, boundaries. Those intelligent machines can be everywhere. One example, of course, here you can see in completely, a self-run factory. It could be basically, imagine as well, we are now talking about self-driving cars. So it could be in many different sectors and of the economy. The third category is Internet of Sensing. And what does it mean? We in the past, we have used the voice sense, I would say, the first generation of mobile technology. We moved on progressively toward the image, and then video, and then now more digital, but we still lacking other senses, like, the touch, like the smell. And if we succeed into integrating this into the reality, this will be, I would say, a huge jump, using the technology for different purposes, not only to meet someone or to examine for healthcare, for different many purposes. The fourth use case categories is about what we call digital and programmable physical world. And what does it mean? It means the barrier you have, of course, we have a digital world, we have a physical world, and we do, even today, we do digital twins of the physical world. We try to anticipate, certain actions, but we still don't have this continuum, this immediate, basically, action and reaction, where you don't feel there is, there is no any difference in these words. And I will exemplify it later on, showing one example how the future can look like in terms, of this cyber physical continuum. So this is about the use cases. We have the platforms. I will talk about it later on, but let me now move on, give you a concrete two concrete examples about the first digital and programmable physical world, and then Internet of Senses. So these are what I have spoken, about the use cases where you have machines interaction, machine to machines, and human to machines as well. Okay, now moving to the Internet, the first use cases, Internet of Sensing. This evolution is straightforward. Now we are, video communication. We are moving into 3D augmented communication. We have AR, VR being tested, being, more on the market, but we are still not there in terms of sensory communication, sensors, being not only everywhere, but conducting for different purposes. And one of these purpose, as I said, maybe the touch and the smell. And let me ask you to pause now for 15 seconds and watch with me, this video, and we'll comment it afterward. What does it say? It's simply you have two persons meeting, one person, physically being there, and another person is being virtually there. But you can see there is a touch, there is a feeling. It's a real meeting, and this is only can be achieved. How it can be achieved? You should have very advanced in terms of devices, in terms of AR glasses, contact lenses, etc. It implies very high bandwidth, isn't it, to be able to project this digital world into physical world. And then at the same, in addition, latency should not be perceived, implying, edge compute and spatial mapping. This is one example, how the Internet of Sensing. Let me now exemplify the second category, digital and programmable world, where, as I said, moving back and forth, into these two worlds. And imagine, for example, in a city where you have, plenty of sensors and data are collected, and this sensors will allow you to take, certain actions to prevent accidents, to prevent, basically, to help people, on their healthcare, and also that citizens can conduct, even, consuming. And let's watch this again, this short video, and let me comment it afterward. So what happened in this video? We are in the city, there's a bus, and there is a bicycle, and the fact that there's a massive amount of sensors, and some of them, or maybe a big amount of them, they are zero energy sensors. They are not consuming, basically, they don't need battery, they don't consume energy. They allowed, to predict or to forecast there is a potential, accident happening between the bike and the bus, and the system immediately reacted, informed the brake of the bicycle to stop in real time in very low latency, and gave the instructions. And as a matter of fact, the bike did strike and avoided the accidents. And this is why is it possible? Because this is very fast. The continuum, as I said, cyber physical continuum, it's allowed to do such a thing. So this is might look maybe very forward scenarios, but these things will happen more and more. It might take 5 or 10 years, but we are heading toward these kind of use cases and scenarios. Now I have spoken, about those use cases. So which are the technologies, that allow us to address, to be able, these scenarios become a reality? What do you need? And if we talk from 6G perspective, what we need a platform that have several pillars. And this is exactly what I will talk about now. Those pillars, four, just for simplifications, and in each of these pillars you have we included many technology solutions, and I will not be able to go into all of them. I think during later today and tomorrow there are some people who will talk more in depth, what kind of spectrum maybe solution you will have, what kind of AR, artificial intelligence, what kind of connectivity solutions will enable these scenarios. And those pillar, now going from from right to left, there is a limitless connectivity. And what does it mean? It boils down that you would assume connectivity is always there when you need it. And how do you reach that? I will come back to it later on. You need further improvement what we have had in the past. For example, you not only have the cellular access, you can complement it, a better architecture construct, a better maybe channel coding, etc., etc. But is this enough? No, it's not enough. There is another very important component, and this is coming into force, what we call trustworthy system. So a system that you should trust. Does it mean that the current system are not trustworthy? I think the current cellular system they have been secure and very secure. You have the authentication is very strong. Nonetheless, what we have made secure, maybe the data pipe, the connectivity, and now this is no longer enough, isn't it? You should make secure, you should not only make secure, but you should be able to trust the data, whatever is the data. Is it on the edge? Is it on anywhere in the system? And also on the top, we have seen, the cellular system also has been vulnerable, on the application level, even on the bottom, it's secure. You can, through application, will be able, to hack the system. For example, remember this Pegasus? There has been a lot of talk how many people have been hacked, on their mobile phones. So trust, this is fundamental element of any technology. Now, there is the third pillar, and this is cognitive network. And you may say, what is exactly cognitive network? Here, what we mean by cognitive network is to use artificial intelligence, not only to use 6G basically will be AI native, some people would call it, and you will use artificial intelligence, machine learning, to not only to improve the operation of a system. For example, if you would like to use a deployment, if you'd like to monitor a site, if you would like to improve the quality of service, but also to introduce new services. And in the standard, of course, also you have seen it's on the agenda at some of the work items, and of course also on not only in 3GPP but also in other sectors. Now the fourth element is network compute fabric. And what does it boil down? As I said, cloud is very important. Now it's also, people have been saying, cloud native, 5G and 6G. And actually it's becoming more and more reality. And it's not only about the storage, in the past, is also about the compute capacity, because you have seen, such a scenario require high computational capacity, whatever on the radio or on the core, and this will be an integral part of the system. So these are, on the nutshell, the four, I would say, pillar. And let me spend maybe a couple of minutes now on the first one, and this is where I would say the core of our business on the network side, to exemplify, what exactly, technology solution will be able to reach this limitless connectivity. And here we talk in particular, one important, we call it, sub journey, allowing to reach that. We talk about the network adaptability. And what is network adaptability? So if you look here at the picture, it's first you have not only the cellular, providing connectivity. This is also being complemented by, you see, a satellite system. And this is where we talk about flexible and dynamic networks, and meaning the integration of different type of access nodes, deployment. And then we should also have the capability to densify in a cost-effective way, and also quickly deploy. I think I will come back to it at the end. What from the industry is also important. For example, we have seen the emergence more of what we call non-public network or local network, and this is more and more. And maybe the capability, some of these networks might be needed for emergency situations, or for more, not only emergency, but also are there to be there for a couple of years to provide certain services for certain enterprise or verticals, not only for critical kind of infrastructures. So this is, one aspect of the network adaptability. There are other two aspects, and other two aspects, like what we say, the network architecture optimization for architecture aspects, and it boils down, not have different architecture to the cloud, to the IT, building a unified and a common platforms, and as well there is a very important element, a programmable device and networks. And this is almost like a dream. If we reach that, will be, I would say, almost a revolution. If you will be able, the capability that the devices is not basically static in terms of functionality, but you'll be able to program them as a network. So you are allowing you to introduce new services and avoiding to go to the standard, and wait maybe a couple of years before these features appear. More like, the IT industry use, like the DevOps approach. So these are, a few, I would say, examples of the technology will allow you to reach what we call, connectivity with no limits. Okay, now let me spend the next couple of minutes, what from the industry, not only from the vendor's perspective. I think, also I work a lot with the 5G ACI, so 5G Alliance for Connected Industry and Automation. And we had a reflection, I would say a first reflection, what is important from the operational technology industry, to the 10 years to come. What are those elements that should be taken into account? And here I list 6 of them. There are more, but maybe the 6, from my perspective, at least the 6 most important. The first one, what I mentioned, that the strength and the support to non-public network, or maybe local, some people call it private. As of today, we have approximately more than 1,000 private networks worldwide, maybe 1,200. It's not too much, and 200 of them are 5G. If we forecast into the future, some analysts would say in 5 years' time, maybe there will be tenfold. There will be more and more non-public networks. And this is important element, when we build 6G, how this will be integrated into the 6G pictures, and make sure, it's also not only working fine, but in an optimal way. Another aspect that we have discussed, and I mentioned only the sensing from consumer perspective and the touch. from the industry, the integration of sensing of communication will allow to reach other objectives. For example, better accuracy to localize things, to detect the unknown environment. And remember, this is important in a factory context, on an oil refinery, or hazardous basically environment. It's important to detect, if there is a temperature change, a pressure, etc. So you can react very fast. So the integration of sensing, would be extremely useful actually for the industry. The third element is advanced deterministic communication. We have been lifting a lot when URLC for 5G, that we need very low latency, but it's not only very low latency, it's also deterministic. And for the future to come, maybe for certain applications like control loops, some of them, it might be useful to target less than 1 millisecond and not only the millisecond boundary. The fourth one is the synchronization accuracy. It's in the order of 100 nanoseconds, so the lower than it's today. And the fifth one, and also it's no exception, the green equipment. If we have sensors, if we have passive, not needing, not consuming power, this is also very important in the industrial context. And finally, the edge, the cloud. This is also will continue to be there in many aspects to offload the system, to offload, for example, the collaborative robots. This is very important. So this is in a nutshell from the industry what is important. And if I come back finally to the 6G timeline, what we say today, like most basically of us, the commercialization of 6G will happen maybe 2030. But there's of course now many uncertainties, isn't it? And this is, because of the geopolitical aspect, because the environmental aspect. This is my impact, of course, the plans. But this is what we foresee. Now, as I said, will these use cases happen, at the beginning? I think probably not. Maybe these most future use cases will happen maybe in the middle of 6G and even afterward. So this is, in a nutshell, our view from Ericsson in the industry. And I invite you as well, to read. I mean, we have published a white paper. It contains only part what I have spoken today about these elements. So that was it from my side, and thanks for listening.
Thank you very much indeed, Afif, for all the great insights. So we'll now turn it over to you, Eric, to give us a bit of an operator perspective.
Thank you very much, Alain. Good morning, everyone. And thank you so very much, Afif, for your presentation, which will allow me to go faster on some of the topics. And I have to say that I'm happy to see that we have quite a good level of alignment between your vision and our vision. But on the other hand, I think I will bring also different points that will complement your presentation. So let me also share my screen. Okay. So the title of this presentation is for a societal and value-driven approach to 6G design. And I think that says it all. I could even stop here, but no, I will provide you some more details about what we put behind those words. So as Afif said, also there are probably some not totally aligned vision depending on the regions of the world. But the general consideration is that 6G will get commercial from 2030. So as we are designing a system that should operate in 10 years from now and from 2030, but up to 2040, of course, what we want for it is to bring value to the society of the next decade. And for that, we need to imagine also what are the problems that we will need to solve at that time. And unfortunately, we have already a lot of challenges today that we know are going to get even worse in the future. And probably that the first of them is climate change. And in orange, we see 6G clearly as a tool that should be shaped in order to provide some solutions to mitigate the climate change. And that means that, of course, 6G has to be responsible when it comes to environmental impact, and particularly to CO2 emissions, which are the direct responsible for the climate change. But also 6G has a role to play to enable other sectors of the society to reduce their own impact on the climate change. And we think that it's really important that we shape 6G so that it can really be optimized to provide the maximum value to that respect. Another challenge is the energy cost and availability cost, because as we see, we have some heavy tensions these days because of the unfortunate events that we all know regarding the energy cost. But in general, as we will move progressively to renewable energy production means, also it will change probably the availability of the energy worldwide. And when you look at some particular regions of the world, like Africa, for instance, where you have a less reliable power grid, also that raises some issue about the availability. And of course, also the more you consume energy and the more you will generate CO2 emissions. So it comes back to the challenge of climate change. And by the way, I would like to make a short parenthesis here. Often when you look at presentations about the 6G performance requirements, you see some proposals to improve the network's capacity by a factor 100 or 1000. And when it comes to the energy efficiency, it's much less. It can be a factor 10 or a factor 100. But if you want to improve the capacity of the network by 100 and you improve the energy efficiency only by a factor 10, that means that your overall energy consumption of the network will grow by a factor 10. And that's totally not possible. In Orange, when talking about our colleagues who are working on the actual networks operations, they say that already today it's extremely difficult to get approved any network upgrade that leads to energy increase, and in the future it will be totally impossible. So that's also a clear constraint that we need to have in mind when designing the 6G system. And then, of course, for the future, you have much more challenges that we will need to address. Afi mentioned several of them: the need for more efficient industry, the need for more resilience, the need to also provide means for a better and more affordable healthcare, and so on and so on and so on. And 6G needs to provide means to address all of this. And of course, that's my favorite. We cannot predict the future. And so even though we know that some of those challenges, they will be important in the 2030s, we cannot exclude that we will have new ones coming that we didn't foresee. And that calls for flexibility in the technology so that we can also adapt, improve, upgrade the technology to face new challenges that we could not foresee at the time of initial design. And when you design a new technology, of course, it's important that you learn the lessons from the current technology. And here I would like to provide some lessons that me, at least personally, I derive from the 5G experience. The first one is that co-construction with the future users is key. And Afif mentioned 5G ACAA, and 5G ACAA together with 5G AA, which is an association gathering telecommunication companies or telecommunication players and automotive players, also to build the 5G that is adapted to take care about the needs of future transportation. I mean, those two associations are excellent examples of the collaboration that we have put in place in the design of 5G together in the same organizations, representatives from our industry, the telecom industry, but also representatives from other industries that 5G has the goal to serve. And this is essential. And coming back to what I was saying about addressing the future challenges, we, telecom engineers, we do not know for sure what will be the status of healthcare in 2035, of our energy production in 2035? What will be the needs of those particular sectors? We can have some ideas, but we don't know the details. So if we want to build a technology that will bring value for those future users in 10 years from now, we need to talk with them. They need to provide us with their vision about how their sector will evolve, how the other technologies also will evolve, so that we can integrate that into the 6G design. So with 5G, we initiated this move to talking with other sectors. But maybe we didn't do as well with talking with citizens, which still today represent, of course, the larger number of users of mobile networks. And we can see some levels of misunderstanding when it comes to 5G. Unfortunately, you can often hear that 5G doesn't bring new services compared to 4G, and at the moment it is correct. But one thing that most people don't know is that 5G is essential already today for us, the operators, and so also indirectly for them, the consumers, because it allows us to expand the network capacity at a much lower cost and energy consumption than if we had to densify the 4G network to absorb the growth of traffic demand. That's for us, that's the main reason why we are deploying 5G now. But most of the people don't know about that. So we have also a stake of a communication to inform all the future users about the technology, what it can do, also what it cannot do, and I will come back to that later in this talk. But talking also with the citizens very much in advance allows us also to design 6G services for which we will be sure of the relevance, of the interest for the people, and so on the return on investment for us who are building the technology and the networks. Associated to that, we need also to be clear on what to expect about the future technology in terms of what it will bring to the people, and also when the different capabilities will come. And I was 2 weeks ago in another 6G conference, the WWRF 5G Huddle, where I had the surprise once more. But that's not really a surprise because that's not the first time, but to hear researchers were involved in the 5G design saying that 5G does not deliver on the promise because we promised with 5G to have lower latency, 5G slicing, ultra-high reliability, and that's not there. But of course, that's not there, but that was planned for the beginning. From the beginning, it was planned that 5G would be deployed in phases. And the next disruption, and Afif mentioned it, will be the deployment of 5G standalone architecture that will provide this lower latency, increased reliability, facility to deploy edge computing and slicing. But I would say that was planned from the beginning. And so that means that even in our community, sometimes not everyone is aware of those technology planning, the deployment planning. And of course, if even ourselves, we are not clear about that within our community, how can we imagine that our customers will be aware of that? And another point also that I would like to mention is that we see a growing interest, of course, on the environmental impacts of the technology. And we are convinced that we need to also be more clear about all the impacts. So the impacts in terms of negative impacts, like CO2 emissions, energy consumption, potentially others, but also about all the positive impacts. And this is something that we have started to do. I mean, you could see some studies from GSMA or the GSI, or also one by OMDAR that was sponsored by Orange 2 years ago, who estimated the amount of tons of equivalent of CO2 that would be saved by 5G in the coming years. The problem that we have with those approaches is that most of the time the methodology used to estimate those impacts, they are not available, they are not published, and they are not published in peer-reviewed scientific publications. And so it lends them, they lend themselves to critics of some people saying, okay, but you are yourself telecommunication players, so of course you will say it's positive, but we don't have, even though you say it, how can we believe you? And we think that really calls for a research effort to build some transparent methodology to evaluate the impacts, positive and negative. And that's also good, and I will come back also to that later on. That's also good for us to build the technology also in order that we maximize those positive impacts with, I would say, more quantitative based approach than what we did in the past. And of course, as Afif mentioned, we have a major disruption on 5G, which is coming in the next year or so, with the deployment of 5GSA that will bring a lot of new capabilities. And we also have much more to learn from this knowledge, from the field operation of those new capabilities in order to take that into account in 6G, because of course 6G will integrate virtualization, cloudification, network desegregation, edge computing, and also support for non-public networks. What it means also is that we should clearly have some experience, some field experience of 5G, of those new 5G capabilities when we will enter the 5G standardization. So we should not start too early, because the 6G standardization, sorry, because if we start too early, then we will not have all those lessons, and we have the risk of potentially not doing things in the most efficient way. So 6G should bring value to the future society. So for that, we have started, I mean, I say we, it's the whole telecom ecosystem has started for a few years to imagine the future services from the one hand based on what we see as being needed in the future, and on the other hand based on what we can expect in terms of performance of the technology building blocks that we are currently studying. And Afif described several of them, so I don't need to repeat that. The point I would like to make here is that so far these are initial thoughts, and we need to analyze them further, all those use cases in terms of technical feasibility, of course, but that's what we do usually, but also in terms of market relevance. What's the real interest from future users on that? And for that, we need to talk with those future users to show them what we have in mind and to ask them what they think about it. And also, we need to evaluate the economic and the environmental sustainability associated to those use cases. And that comes back to my previous point about the need to have methodologies to estimate the impacts. Because if you think that having, for instance, digital twins needs much more, in the end, energy consumption or much more sensors deployed everywhere, and that the impact, the negative impact, is larger than the positive impact in terms of reducing the CO2 in different sectors, and probably we should not do it. I'm not saying that's the case. On the opposite, I'm quite confident that it's an excellent solution to reduce the energy consumption and the CO2 impacts. But this is something that we should get confidence about. And the last point is economic sustainability, because of course, if we imagine technologies that will solve a lot of problems and that we could build from an environmental sustainability perspective, but the cost is so high that there will never be any return on investment on that. of course, that will not fly neither. So we need to study all those aspects in order to make sure that we are building services and technologies that will really be able to be deployed in the real world in 2030. And for that, as I said before, it's really important that we have this thinking about the use cases with the future users, also because when it comes to particular sectors, they are the ones who know better what will be their needs in the future. So in terms of performance requirements, we think that we should not get extreme performance requirements just because we can. Providing 100 gigabit per second is excellent from the technical perspective. I would love to have 100 gigabit per second when doing a speed test in a 6G phone, but we should do it only if it brings value in the end. And for that, again, we need to have a dialogue with the future users to know exactly what they need and not to over-dimension the system. And then, of course, when saying that, there is always the debate of saying, yeah, but you know, no one could imagine what would happen with all the apps that came with 4G when we designed 4G at the beginning. And yes, that's true. So probably that we will have some developers who will use all those data rates that we can provide in the future. And we should not also close the door to innovation, but still we should have enough confidence on the real need of the increased performance that we are designing by identifying already beforehand some services that will use them. Otherwise, we would be, at least we in Orange, but I think that several other operators have the same concern. We would be cautious in investing in new technology if we are not confident about the return on investment. And that means that, again, we need to develop some methodology to evaluate the value. And value is not only euros or tons of CO2 saved. It can be very different metrics, and that's why it's not an easy task. But still, we are convinced that this is something that we should do in order to set the performance requirements properly. And of course, performance is important. If 6G doesn't bring any performance change compared to 5G, we would not be a 6G. But so there will be a need for increased performance, definitely. The question is where to set the requirements. But performance is not all, and we are strong believers that for 6G, we need to take into account, with the same level of importance, increased performance and what we have called societal requirements, which are summarized on the slide here, where you find energy efficiency, which was taken into account already from the 5G design, but also what we call end-to-end environmental impact, which includes not only the energy consumption, but also all the impacts on the environment, including the CO2 emissions emitted during the building and the end of life of the hardware. Also the impact on the materials, and we need to account that globally, taking into account really all the steps in the value chain, from extracting the minerals from the soil up to the recycling. And this is what we need to do if we want to minimize the environmental impact of the technology. Security and resilience, also, these are not new requirements, but we need to increase their levels because we already, the mobile communications are critical for the proper life of the people, of the society, of the public services. But as you will get connectivity embedded in more and more critical systems, you need to have higher and higher security and resilience requirements, because we will less and less be able to accept any service disruption. Digital inclusion also is an extremely important aspect when thinking about future technology, also because you have still billions of people in the world who are not connected, who do not have access to the internet, and this is something that needs to change. And the last one is what we call exposure awareness, and it is about the exposure to the electromagnetic fields which are generated by the radio networks. And as you know, we operators, we are subject to regulatory constraints when it comes to exposure. Today, the networks operate at a power level which are much less than the limits which are recommended internationally. However, there are some particular cities or countries which have adopted much lower limits than the ones which are internationally recommended, like 10 times less. For instance, Paris or Brussels or Italy. And in those areas, with the 5G deployment, we are getting close to those limits. That means that if we don't change the way we are designing radio networks, it's possible that 5G will be the last time that we can add new frequency bands, because each time you add a new frequency band, you increase the overall power transmitted by the networks, and so you're getting closer and closer from the limit. So that means that we need to invent ways of increasing the capacity of the networks, increasing the data rates, increasing the number of connected devices, but without increasing in the same way the electromagnetic fields. So there are technical solutions for that, like the reflective intelligent surfaces or the zero energy devices that Afif was mentioning before, which do exactly that. And so that's also a research area which is becoming very active now. So all those societal requirements, they're required to define some new indicators so that we can clearly set requirements for them. They require new tools also to be able to evaluate them, and of course technical solutions in order to make the technology compatible with those requirements. And at last, and this one is particularly important for us operators, we have operational requirements. Automation, I think Afif mentioned it, is extremely important to minimize the need for human involvement into the network, being able to adapt quicker, also in case of failure. We need also to be able to adapt the requirements. For instance, in a very crowded area, we probably may want to favor capacity against energy saving, but in the middle of the night, then probably that the network should be optimized for energy saving rather than capacity. That means that you have the network should be flexible in terms of adapting to different optimization trade-offs. Of course, we need to be flexible to accommodate future evolution for future needs, future services, and we should also be able to have dynamic software upgrades without having to stop the equipment. And last slide before the conclusion, it's just a very high-level representation of how we see the 6G development roadmap. So on the top, you have the, I would say, technical roadmap. Then in green, the use cases. So as I said, so far we are in identifying initial use cases. The next step that we see starting from 2023 will be to validate those use cases against a dialogue with the future users, evaluating also the cost of delivering the services, and evaluating also their environmental impact. And as you can see, we see the need for having the dialogue with the future users to start quite soon, because it's really important that in the end, we are confident on the technology that we are going to define here around 2025, when we will engage into standardization, which will really carve in the stone, if I can say that, the technology that we will then specify and build and deploy. So I had two next slides about technology aspects that I will skip for the sake of time. And just to summarize, so we strongly believe that 6G has to provide value to society in a secure, resilient, environmentally and economically sustainable way. And that goes for research challenges, as I said, to develop the right value indicators and also evaluation methods of the positive and the negative impacts, which is shared between us. So it requires some science. We need also to base 6G on performance requirements, of course, but also on societal requirements. And here again, we have some research challenge to define them and to build the methods to assess them. And at last, we think it's really important that we make 6G also with the future users of this technology. And for that, we need to create a dialogue with representatives of the society, including the citizens, but of course also industrial sectors, public services and regulators. And we need to start this quite soon because we think it's really important that we have confidence based on their feedback on the technology that we are proposing before we engage into standardization. And as standardization is planned to start from 2025, then we think that really from 2023, we should launch this dialogue. Of course, all my presentation was devoted to 6G, but what I've said here is true also for fixed networks. And my last point will be for research. As we know, constraints stimulate creativity, and we have a lot of constraints here. So that probably will generate a lot of very useful innovation for the future. And I will stop here. If you want more details, you can also have a look to our white paper that we published a few weeks back. Thank you very much.
Right, thank you very much, Eric, indeed. So with this, we'll kick off the panel discussion. So I will kick off with a question around the lessons learned actually from 5G. So it's quite obvious with what you said, Afif, on 5G not delivering on all its promises so far. But these are coming, and also what Eric, you elaborated on some of the lessons learned already, right, and how we should be doing things differently, right? So the question is really simple. So how can we actually do things differently for 6G so that the promises of 6G would not be disappointing? Let's put it this way. So would you like Afif to kick off on this?
Yeah, thanks. Maybe two aspects to begin with. The first one, I think also Eric mentioned it, at the beginning when we were designing 5G, we were trying to predict the use cases, especially for the industries, and we did not really engage with them, or it was too early. They were not really very interested as well. Now we have a big differentiator that we have learned. We are already engaging very closely to industries to begin with, manufacturing and automotive, and this is an added value. We have learned the lesson. We would like also with other industries. The second aspect, I would say, maybe not to move very, very fast, and maybe to take the time and not to only multiply numbers by a certain factor. This is very important. It's like multiply the capacity by throughput by 10, etc. We have to look after what we really need or what potentially can be needed, and maybe keep the technologies flexible enough. So if basically it allows you to reach certain KPIs by adjusting the technology.
Okay, yeah, thank you, Afif. Eric, so what's your perspective on top of what you shared already on the lessons learned?
Yeah, so as I said in my presentation, how to do things differently. So we need to engage with the future users. And I think we also need to prove or to estimate in advance what will be the benefits that our technology will bring to different sectors of the society. And you may have seen those studies I was referring to from GSMA, GSI, or OMDA, forecasting like the millions of tons of CO2 equivalent being saved, or that will be saved by the 5G operation. So we did that after 5G was deployed, but we probably could try to do it before the technology is deployed, even when the technology is being designed, so that we can also steer the 6G design so that we maximize this value. Of course, it is easy to say, difficult to do, because there are a huge amount of potential applications, and probably for each application you would need to make this analysis. So the goal is not to do it for everything that is possible, but maybe to select a few numbers of important applications that we know will have an impact, and try to do the exercise on that. But again, that's really a research area at the moment.
Mm-hmm. Okay, yeah, that's perfect. So staying around the same...
If I may interrupt, I didn't mention other aspects that Eric mentioned, but I would like to say, of course, I fully support them. The one, for example, on EMF, should begin the discussion right now, and we should not try basically to disregard it or say, no, this is not a problem. We should take this discussion already, from the beginning. It's very important. There is also a problem of trust, and we have seen it, with conspiracy theory. There is trust, because there is a frustration. It's not only about, telecommunication. Of course, I mean, citizens feel overwhelmingly monitored as well, and there is something, on the top being, decided for them. And that's why it's very important, as Eric mentioned, and as Orange is also saying, engaging, with society is of a crucial important. The decision making should not only be made by technology and politicians, and we have seen this is having impact everywhere, and not to be neglected. And finally, actually, also many youth, for the environment, this is of crucial important. We should not put it, as a second priority, because many people are saying, look, our, for our future, for our children, environment is important, sustainability is important in all dimensions, and not me, CO2 emission, of fairness, of basically, trying to have a more peaceful world. These are, and technology do have implication, because technology can be used, to pacify, and as well as a tool, aggressive tool as well. So these, I wanted to compliment as well.
Yeah, that's brilliant. Thank you, Afif. So staying a bit around the same topic, so how can you actually translate these, if you like, societal, green, sustainable kind of requirements into KPIs or equivalent in the ITUR?
Yeah, that's very tough indeed. So maybe for some of those requirements, we will not be able to come up with a KPI. But we could come up with recommendations, or maybe not recommendation, but other types of requirements that would be rather on the way we need to define the technology. We know that when it comes to CO2, we know that the renewable of the hardware is one of the renewal of the hardware is very important. The longer you keep your hardware, whether it's your mobile phone or your network equipment, the less CO2 it consumes when taken from during its whole life cycle. So you could imagine to have some requirements for modularity, so that if you have one part of the equipment that is failing, then you can easily replace it without to have to throw away the whole equipment. That's a way. And by the way, there is an NGMN deliverable that was published last year on the network eco-design that provides a very thorough analysis of everything you can do from that respect. So I invite you to have a look at it. That having said that, there is also, that's not that simple, because you have also a compromise regarding, I would say, the CO2 which is generated from the equipment manufacturing, which is linked to how often you renew the equipment, and also its energy efficiency. You know that every new hardware is much more energy efficient, which means that for the same tasks, it will consume less energy when in operation. So what you need to factor in is the impact on renewing the material, which is related to its embedded CO2, and also how much energy it will consume during its living period. And you need to take that into account if you want to have the global estimation about I would say, when to renew your equipment. And I was told recently that there are some studies at ITU that provide such methodology. So these are the types of considerations that are becoming more and more widespread in our industry, and that, of course, we need to use and develop for 6G.
Oh, yeah, that's great, Eric. And if I may comment on this, so as you know, I mean, the process in ITU is quite, straightforward in terms of, vision, technology trends, requirements. Then, the standard bodies go and define the spec, and they come back, and there's an evaluation, process that takes place, and then we have the recommendations. So what I derive from what you're saying, Eric, is that hopefully these aspects around societal requirements would find their way, one way or another, right, in some form of evaluation methodology, a new evaluation stage in the ITR. Right, so that's what I derive from you. Afif, would you agree with that, or what's your thoughts on this?
Yeah, maybe I would like also to make this, as we have not necessarily discussed it within, only Ericsson. It's maybe certain KPIs, it's not only about energy consumption, producing less CO2, it's also the exploitation of certain material. If we take, and the devices and the hardware we are producing, there are rare, basically, material. And maybe we should at least, have, KPIs as well, how much is consumed, of rare materials to make, because this is very relevant. Another idea, Eric said we cannot usually disconnect, the internet or the fixed from the wireless as well. For example, we can data centers, if they are not placed within, within the vicinity of operators, these will consume, isn't it? Because you are using the wireless connection. And maybe there should be as well, this should be taken into account. So not pushing the consumption somewhere else as well, isn't it? And the consumption also can be used at home. So this should be, this dependency should be really reflected.
Absolutely. Yeah. Thank you, Afif.
And if I can add one word about what you said, Alain, not everything about those sustainability aspects are tied to standardization. You have also a lot which has to do with implementation, which is not standardized.
Yeah, absolutely, Eric. Yeah. All right, so I will pick one of the questions that we have actually in the Q&A box. So the question is, can we afford to create new networks like in 4G and 5G? So who would like to jump on that one? Eric?
Yeah, so actually, yeah, so if you take 5G, for instance, 5G is not exactly a new network. We are using a lot of the 4G infrastructure. For instance, when for the current 5G NSA deployment, we are reusing the same antenna sites. We are merely adding the new antennas and the new RF equipment and new baseband, of course. But all the rest of the infrastructure remains exactly the same. Things will change when we will deploy 5G SA, because of course we will deploy new 5G core network functions in a virtualized way, so also on new hardware. So that will be a much more important change. In general, that relates, the way I understand this question is more about the cost. Can we afford to invest again a lot in order to deploy a new network? And that's a matter of return on investment. We can afford to invest if we know that we will get some return on investment. And that's why also I said that we need to build confidence on the technology that we are designing, from the value it will bring to the consumers, and also from its relevance in terms of market and revenue and the return on investment. If we're confident, then yes, we can go ahead. If not, then that's another matter.
All right. Yeah. Thank you, Eric. Afif, would you like to comment on this?
Eric also mentioned it. It depends how are we going to design, as well 6G. If for example, the waveform is entirely changed, it will allow you to change the hardware. This is, maybe it might be problematic. So we have to think twice. Is it worth it or not? And then if this is transition like between 4G and 5G, we kept certain characteristic, and it doesn't really have impact. In the contrary, we made, the consumption, already mentioned it, less, because you turn off, certain cells when you don't transmit the control signaling. And this has been really efficient. So, and maybe people also don't know about these details. These are very important as well to lift them to the top. And implication, of course, on the design of 6G, not to make, if we make things entirely new, then it should be justified. There is a return of investment.
All right, brilliant. I think with this motto from Afif, we come to our time, quarter past the hour. So thank you very much indeed, Eric and Afif, for all the insights. Thank you for the audience for listening to us. And as the last comment, this session is going to be available next week for on-demand watching. So thank you very much and enjoy the event. Bye-bye.
Thank you very much.